So we're going to talk about the fundamentals of turning. And often when we talk about the lathe, the operations that we do on the lathe are often called turning operations rather than saying, I'm going to go lathe this part. Well, we don't say that. We say we're going to go turn this part. So that you'll hear the kind of interchange there. Sometimes we'll talk about the lathe, and then when we talk about the functions, we often will say, I'm going to go over and turn this part, and we associate that with work that we'll do on the lathe. So all we're going to really get today is kind of a baseline, right? I want you guys to be familiar with some of the very basic parts of the lathe and what what the lathe can do, what its capabilities are. How do I know if I need to put a job up on the lathe instead of put it up on the mill? There's 5 machines that we will be discussing in some depth during this course, and one of those 5 machines is the lathe. So really the fundamentals of the lathe is what does it do, right? How does it work? What are the parts of the lathe called? The accessories section that we will be discussing will be more about the add-ons, right? So how can I hold work? Well, what options do I have to put work into this machine or a workpiece? How do the tools get mounted? And how do I mount a tool? How do I support the work? If I have a long piece of work. And then, of course, we want to know how to use the lathe safely, and this includes not just mounting the work properly, but it also includes how to properly set the spindle speed, how to set the feed rate, use the automatic feed, how to thread, etc. So I'll just kind of do a little pan around here of this particular machine. Now, this was in my machine shop before I sold my shop. This machine is kind of a little bit bigger than what you'll have on campus. This has approximately an 8-foot footprint, but we wouldn't classify this lathe as an 8-foot lathe. So one thing that you will want to remember, and if you go and write your certification, if you take an apprenticeship, like a complete apprenticeship, and you want to write your ticket, one of the things we need to know about a lathe is how we determine what the size of a lathe is. And why this is important is because when we're at a job and the boss comes up and says, I need you to cut this part, I need you to make this part on your machine. Your machine, the size of your machine is going to determine whether or not you can put that part up. So there's 2 things, right? There's 2 things that we want to understand when it comes to the size of a lathe. So I'll just put this up on the light board for 1 second here. So the 2 things that determine the size of a lathe, one is the largest piece of work that can be put up between the centers. So really the distance between the centers. Okay, so that is from the center of the spindle to the center of the tailstock, right? So this distance here is one way that we determine the size of a lathe. The other way that the size of a lathe is determined is the amount of the swing. So that's going to be from the center of the spindle, right, at the headstock, center of the spindle. So the distance from here to the top of the bed. Okay, so it's the distance between centers and the size of the swing. Okay, so that's the two ways. So when I say that this machine has a 8-foot footprint, what I'm saying is this is just the overall size of this machine. But for me to manufacture a part on this, it doesn't really help me unless I know those two pieces of information. Okay, let's just move on here to our next slide. So there are three main parts of the lathe. So I would recommend that if you do not like to go back and watch these videos, that you take notes of things so that you can fill in your assignment later, okay? But I would highly recommend that you go back when you're doing your assignment and go to these key parts to fill in the information that's missing. Okay, so three things that were three main parts of the lathe. We'll get into those in just a moment. More on the fundamentals of the lathe. So the work holding, it mounts to the headstock, okay? And the material is mounted in the work holding. So you'll see right on the top right hand corner, maybe I can change this view here just for a second. Okay, so you'll notice, so up in the top right hand corner of this video, you'll see a 3-jaw chuck, right? 3 jaws. So those 3 jaws, we call that a 3-jaw universal chuck. And why we call it that is because when you tighten the screw in the side of the chuck, which is the middle top picture, okay, that's looking at the chuck from the side. I don't have the keyhole showing. You see a different one there, but there's 3 keyholes around the periphery of that 3-jaw chuck. You can tighten any one of those, and all 3 jaws universally will close, or if you turn it the other direction, they will loosen. So that's a 3-jaw universal chuck. It will mount on the spindle face, and when the spindle turns, of course, it's going to drive this chuck. So while the material is turning, we bring the cutting tool, which is usually mounted on the carriage. So the first main part is the spindle. Okay, so that's part at the top where the work holding goes. The second main part of the lathe is the carriage. So the cutting tool is mounted on the carriage system. So not directly on the carriage, we'll talk about that in a few minutes, but the cutting tool is mounted on that carriage system. Okay, and then the third main component of the lathe is the tailstock. So these are the 3 key pieces, okay? Headstock, carriage, tailstock. Now, the tailstock, the purpose of it, essentially, one of the big purposes of it is to support long work. So you can imagine when I was talking about the way to determine the size of a lathe, it's the distance between the centers is one of those ways, right? So on this particular machine that these pictures are taken from, the distance between centers is 48 inches. So, try and imagine just for a moment. I mean, you don't have to have ever worked on this machine before to understand what would happen if I took a 48-inch long piece, right? A 48-inch long piece of material. And I put it in the spindle, right? And it's 48 inches long. And I tighten up the 3-jaw chuck and I turn the spindle on. So, I'm holding on by whatever amount of material, but you can imagine all of that material hanging out of that 3-jaw is just going to do this. So the tailstock, what we can do is we can support that long work, and we do that by means of this at the end of the spindle here in the tailstock. I don't know if you can see my mouse here or not, but right here, the end of the spindle is a center. and this is the live center, and we'll talk a bit more about that in just a moment. So let's go through the bits and pieces here of these three main components, okay? Number one, let's talk about the tailstock in a little bit more detail. So the tailstock, it slides along the ways to and away from the headstock, compensating for the length of work, as you can see here in the demonstration, right? So I can lock that tailstock, as was just demonstrated there. I can lock it to the ways so that it will no longer move forward and back. Now, the reason for this is that not all work is going to be the same length. I may need to support a piece of material that's 30 inches long, but I may also need to support a piece of material that's 12 inches long. So I need to be able to slide that tailstock on those ground and lapped ways and bring it closer to or further away from that headstock. So another thing about the tailstock is that spindle at the front of the tailstock will accommodate, as you can see here, it can accommodate a live center. So that live center, basically, it's a center that spins with the work. So that's got bearings in it. And so as you push this tailstock up against the workpiece that's being spun in the spindle, you can imagine if this center was not live, if it was a dead center, that material would just rotate around it. The center would still support your work, but the work would spin around the center, and you can imagine how much heat would be generated. It wouldn't take long before your part melts against that center. So this center that you see here is a live center, so it moves in rotation with your work, but still keeps the part centered and supported. And then lastly, there's the two pieces of casting that really form or make this tailstock. You have the upper and the lower casting. So the upper casting in this particular on this particular machine has 4 bolts, and I'm pointing at one of them there in the picture on the left side. So those 4 bolts you would loosen, and you know, if you can picture this in your mind's eye, that tailstock, as I showed in the first video, will slide towards the headstock and away from the headstock. But sometimes we need the tailstock to move 90 degrees from the ways. So if you were standing in front of the tailstock with, looking at that picture on the bottom left there, so if you were standing directly in front of it as though you're looking at it right now, the handle's on your right and the spindle's on your left, I can loosen those 4 bolts and push that tailstock away from me or bring it towards me 90 degrees from the spindle. And that's important because there are times that we need to cut, in one instance, we need to cut a taper, a long taper on a piece of work. So we can actually shift the material off center so that at the headstock, it is, at the headstock, it's sitting in the spindle, or against, it would be against a center. But at the tailstock side, here, I'll put it up on the light board here so you can see. On the tailstock side, draw it up here for you. So now we're looking down on the machine, okay? So this is our headstock still, okay? We're looking down from the sky. And this is my piece of material. Okay? This is my live center in my tailstock. Okay? So sometimes what we want to do is we want to create a taper on this part. So we essentially, what we want to do is we want to make this part taper like this, right? So we kind of want to create this tapered surface. Well, to create a long taper like that, what we need to do is we need to move this tailstock either away from us or towards us, right? Depending on which direction the taper goes. So the 4 bolts that you saw on the tailstock, 1, 2, 3, 4, you'd have to loosen those. And then if we, instead of looking down on the top of this tailstock, if we look at it like we saw in our picture, our tailstock like this, right? And the hand wheels here. Okay, so there's our tailstock and there's our spindle. Okay, so once you've loosened those 4 bolts looking down on the machine, which are here and here and 2 on the other side, there's another set screw right there once those bolts are loose. And as you turn the set screw to the right, it pulls this tailstock towards you. When you turn the set screw here to the left, it pushes the tailstock away. So that's a really nice feature to have on the tailstock, because what that allows us to do is set up for long tapers, and we can cut tapers almost the length of the distance between those 2 spindles. Just a little bit we won't be able to reach, which we can talk about that at another time. Okay, let's move on to our next part here. So this is the second part. So we talked about the tailstock in a little more detail. Let's talk about the carriage. Now the carriage, it has a lot of options and features. Okay, so the carriage moves parallel to the ways. Now I've used the term ways a few times, and what the ways are is you'll notice on the top of the machine, kind of like that shiny. Can you guys see my mouse when I do this, or no? You see anything? Okay, I don't hear anybody, so I'm gonna assume that you can.
Yeah, we can see it.
You can? Okay, perfect, thanks. So this right here is the ways, guys. So these ways, they travel from the headstock all the way down to the end of the tailstock. Those ways are ground and lapped. In other words, they are extremely flat and true and parallel. And so we need that, because if we're going to cut anything at any length to any sort of achievable number, or to any sort of precision, these ways have got to be accurate, because think of it kind of like the rails for a train, but 1,000 times more accurate. Okay, so this carriage will ride those rails or ride those ways back and forth, and so will the tailstock, and they got to be true, or we're not going to have any success when it comes to making any parts with any sort of precision. So the carriage moves left and right in the x-axis along those ways. So it's not stated here in the video or in the presentation, but you notice where in the bottom picture where my hand is on the hand wheel. Right behind that hand wheel, it is a piece of is a cover. You'll see to the left of it are 2 levers. So that hand wheel and the 2 levers, they are stationed in front of the apron. So the apron is the part that's on the front of the carriage, and not unlike an apron that we might wear in the kitchen, but to keep things from spilling on us or splashing on us. It's the same idea. This apron is fitted onto the front of the carriage to prevent dirt and chips from falling down inside the mechanisms there and the gears and making a mess of things for us. So really that apron is just a cover, and then the hand wheel is in front of it, or it goes through it, and then those 2 levers, which we'll talk about in a moment. Okay, on the top of the carriage, so the apron is the front, 90 degrees from that, on the top, that is the saddle. If it helps you to think about, what we put on the top of a horse, okay, or whatever, that's the saddle. The saddle sits on top of the carriage. Now, on top of the saddle, so I'm going to see if I can point to this here. So this section right here, so from here, around here, and then it goes all the way to the back, and then back along here. This is the saddle. This is the apron. This is the saddle. Okay? On top of the saddle, you see this device right here with another hand wheel. Okay, so this is the cross slide. And the cross slide, if it helps you to remember it, it travels across the ways. Okay, so the carriage travels with the ways, left and right, or in the x-axis. The cross slide travels across the ways in the y-axis. And this handle here, this is the handle, and I'll show you the video in a second. This handle controls the movement left and right along the x-axis. This handle here controls the cross-slide motion across the ways. And then sitting on top of this cross-slide is this little unit right here with another handle. This handle here is the compound rest feed handle, and this is the compound rest. Now the compound rest has 4 bolts, and I'll show you that in the video as well. You loosen those 4 bolts on this particular machine, and you can rotate that compound rest around 360 degrees so that you can achieve any angle that you need to approach that work. On the top of the compound rest right here, guys, is the tool post. Okay, so a lot of times I'll mistakenly call it the tool holder. That's not accurate. This is the tool post. The tool holder would sit inside, right? So sometimes tools don't have a tool holder. The tool will just sit right in the tool post, but sometimes you need a special holder for specific tools, and then that tool holder will slide in there. But so there's not confusion, this is the apron, this is the saddle, this is the cross slide, this is the compound rest, and this is your tool post. Oops, let's go back. Sorry about that. All right. Oh, I'm going the wrong way, that's why. Okay, so here we'll just do, wow. Okay, let's try that one more time. Sorry, guys. And there we go. Okay, so here's just an example how the carriage moves along the ways, how the cross slide moves across the ways, and then the compound rest will travel on whatever angle you set it. So here's how you adjust the compound rest on this machine. The machines that you're going to use will be slightly different, but the concept is the same. You would loosen the bolts, rotate the compound rest to whatever angle is necessary to create whatever the feature is that you're trying to create. And then once you have cut that feature, or once you're ready to cut that feature, you would tighten down those nuts so that you could go ahead and do that. Okay, let's go to the final main component here. So the headstock, really this is where all the power is, guys. So there's typically on a lathe, there's only one section that is under power, and that's the headstock. Now there are, I say typically because there are some lathes out there, manual lathes, that even have a powered tailstock. Very rare, but they're out there. But when we talk about where the power is on a lathe, it's always at the headstock. Okay, so the workpiece, as you see in the top left photo here, the workpiece is mounted in the work holding, and in this case we still have our 3-jaw chuck mounted. And the way this works is there's a motor, the main motor in the lathe, it will drive the spindle in older machines anyways, it will drive the spindle with belts and pulleys. So when that main motor kicks on, and you set your rotations per minute, by means of those pulleys and belts, it will spin your spindle to whatever RPM that you've set. Now inside the headstock, if you look at the top right picture there, inside the headstock, looking at it straight on, you'll see a bunch of levers on the top left, on the very top, and then on the front. Those levers all have different purposes, and instead of me saying this lever does this and that lever does that, every machine is a little bit different in what it offers as far as where the levers are, what they do, and how intricate things are. So in this particular case, the lever on the very top sets the high and low gear. The levers below it allow me to set my RPMs, those two sets of levers right below the top. And then the three levers across the middle there, they allow me to set my feed rate for my auto feed, and they also let me change it from auto feed to cutting a thread. So that's how this machine is set, but you won't be tested on what these levers do because every machine is a little bit different. So when you get onto a machine, just make sure you know, you get a thorough walkthrough on how to set your RPM, how to set the high or low gear. Did I just lose you guys? Are you guys still there? Something just happened. Oh, never mind. It's back. I don't know what that is. Okay. Where was I? Oh, yes. And then as long... Hold on. Can you guys still hear me?
Yeah, we can now. The last few minutes, though, nobody could hear anything.
Oh, that's very strange. Okay, have you heard anything on this slide yet, guys? Okay. Can you still hear me? Oh, shoot.
Yeah, I can hear you now. It doesn't show your name up with everyone else's name now, though.
Yeah, I don't know. I think it's something to do with the storm. I may have to. I may have to be brief here. If I lose you guys, I'll continue the recording and I'll post it regardless. I'll just wrap up this last slide then. Just so that we're clear, top left picture here shows the workpiece in the 3-jaw chuck. This is the headstock looking straight on it. All of these levers do different things on depending on the machine that you're working on. Okay. On this particular machine, this is my high-low gear. These levers let me set the RPM. These levers here let me set the auto feed or set up to cut a thread. But don't worry about that. When you get on your machine, you'll be instructed on what levers do which so that you can operate the machine safely. So if we just look at this first video here, this is just an example of a simple cut on the outside diameter of a piece of work. This is one of the operations that we can do, one of many operations. But this is where we can cut an outside diameter. Primarily what we cut is round stock. When we talk about round stock, this is exactly what we're talking about, round material, cylindrical material. But that's not by any means all of the material that we can cut, okay? Here's a second video. Here's us cutting the bore, or cutting a bore, right? So this part would already have had a small hole in it, but now I'm opening up that hole to a specific size with a boring bar. So just two small examples of work that we can do on the lathe. But as you're going to see in the experience you get in the shop, there are so many options and so many setups. Your imagination really is going to be the only thing that limits you in what you can cut. Now, this is a really important slide, guys. So if I lose you or you lose me and we're back together, make sure that this gets repeated, okay? All of the features that this machine has and all of the things it will let you do, none of it is any good if your tool is not set to the center line of the spindle. So what I tried to do here is I tried to show you in the picture on the top left, the tool brought up against the live center in the tailstock, because the tailstock center and the headstock center, when they're both installed, when you bring the bring the tailstock up to the headstock, those two centers should touch right on. So our tool has to be set so that it is right dead on the center line. If a laser was coming out the center of that tailstock, your tool needs to be able to split that laser in half. That's how you want this set up. In the top left picture, it looks like the tool is on center. In the bottom left picture, it looks like the tool is on center. But for you to know if your tool is on center, by eye, you need to get down and change your perspective. You need to look at where the tool comes up to the center from the side. So you'll notice in the right side picture that the tool is actually too low. It is actually sitting below the center line. So the bottom red line there is where the tool is currently set. The upper red line is where the center of the spindle is. Now, how big of a problem is this? Is it a problem? So, the only way to really think about this is if you had a piece of work between the centers or in the three-jaw chuck, and then you had this live center up against the end. What you do know for sure is that part is centered on the spindle and the tailstock. So that part is centered. If your hold on. For some reason, Zoom keeps kicking me out. So, all right. Now, if you were to cut the end of the workpiece, so I'm gonna just switch us over to the light board here, and I hope that you can still hear me. Okay, so let's just take this off. And let's just take this off. Okay. All right. If you were to have the tool set up the way we saw, okay, and so here's your tool, all right, and you want to cut the material off the end of this workpiece. Okay, so this is your material, and you want to bring your tool across here, right? You want to come across with your cross slide and face off. We call this facing, okay? When you cut the end of the workpiece, we call it facing it. So if your tool is sitting too low, if you look on the end of the workpiece here after you cut it, you will have a nib right in the middle, because your tool, when it cut across, it cut across here. It was sitting below center. So what happens is any material that is above the center line, the tool doesn't cut, and it leaves this little island in the middle of the workpiece. Counter to that, if your tool is too high, right? If your tool is too high and you cut across the material, Any material underneath here that's below the center line will often go black and be all beaten to garbage. Because what you're trying to do is you're trying to force the underside of the tool to move material. And all it does is just mash it up. So it is important that we set up our tool so that we cut along the center line and we won't have any little island in the center here whatsoever. Now, how accurate do we actually need to be? Like, how important is this? Is there any room for error? So a tool, like the end of the cutting tool, will have a radius on it. So let's just imagine we zoom right into the tool tip, right? No tool tip is sharp like this, because if it was, it would snap off right away. So there's always a small radius on the end of a tool. Okay, so this small radius allows us, if this is the center, let's see if I can give you an idea here. So the center of the tool is going to be somewhere behind the tool nose, right? So there would be our theoretical cutting point right there, right? That would be this. But because we can't have a point, we have to have a radius on here. This is the theoretical center. So there is no point, right? There is no point to touch off of and say, this is exactly on the center line. So what we need to do is we need to bring this radius tool as close to center as we can. And we're looking at it, see if I can flip back to the screen so it makes a little more sense. Looking at the tool right here, we don't see this radius on the end of the tool. We just see a line at the end of the tool. That's what we want to use to set our height. Okay, so this tool right here, where it comes to the end, this just looks like a 90-degree corner. So we want to use this. It's not actually a point, it's the side of a radius, but we want to use that to set our height. But if we cannot get it exact, remember we're doing this by eye. If we cannot get it right dead on, then we need to make sure that we're slightly below. On that little drawing I did on the light board, it would be far more advantageous to leave a little tiny island in the center of the face of that part than to have the bottom of that radius rubbing material away. Because what that will essentially do is wear away the underside of your tool. Besides ruining the end of your workpiece, it will wear down prematurely your cutting tool. Okay, so if you cannot set your tool exactly dead on center, then set it just below, almost indistinguishably. We usually tell students 10 to 15 thousandths of an inch. Okay, so 10 to 15 thousandths of an inch, we're talking about 0.01 to 0.015 inches. Now, you may say, how in the world am I ever going to know if I'm 10 thou to 15 thou below center? By the end of your few months in this course, 10 to 15 thou is a mile. You will know if you're out 5 thou, 0.005. This is part of that feel that we were talking about last week. Okay. All right. Let's move on here. I want to talk a little bit more about lathe accessories. So first is the work holding. So I told you a little bit about the 3-jaw universal chuck. When you turn the screw on the side of the 3-jaw chuck, all 3 jaws move universally. So key word, universal, right? 3-jaw universal chuck. All 3 jaws move at the same time. You have another option of a chuck, and that's our 4-jaw independent chuck. Now, the reason why we would use one over the other, the 3-jaw chuck, I would use for any round work, any hexagon work, any triangular work, especially if, I'm really only working to, maybe a couple thousandths of an inch in accuracy, 0.002. Those three jaws will pretty accurately open and close at the same rate and close exactly or close to exactly every single time on the same workpiece. But you can imagine though, if you put too much pressure, if you take that wrench and you just tighten and tighten and tighten that screw, you can indent your work, and that can change how far your jaws move, right? And then actually throw your work out of size a little bit. But really, the three jaws, they will close the same way every time. The four jaw chuck, why I would use that is if I need to make sure that a piece of work is being held exactly on center. So if I had a piece of square stock or round stock, those four jaws are going to be an equal distance from the center of the spindle. But I can also put a piece of rectangular work up in a four jaw chuck, because each one of those independent jaws move independently. They all have their own screw. So I can move two of those jaws further out to accommodate the long side of a rectangular piece of work, and then dial the two other jaws in. The nice thing about a four jaw chuck is that you can actually control the exact location of each jaw so that the work sits on center. On most of these manual lathes, you can dial your work in so that it's 0.0005 inches in accuracy. So 5/10 of 1,000th of an inch. That's how accurate these four jaw independent chucks can be dialed in. Now, mind you, guys, some of this has to do with the age of your machine, how many times it's been crashed, how many times you've run a tool into the four jaw chuck. So there are other things to consider, but in a perfect world, these four jaw chucks will allow you to get quite a great amount of precision in centering your work. We did talk about a little bit the centers. So any long work that we put up that needs support, we can support it with a live center in the tailstock. Now, you can put, absolutely 100%, you can put a dead center in a tailstock. Okay, so a dead center does not have a bearing like what is being demonstrated in the top video right now. The dead center below it is exactly that. It's just dead. It does not spin. So your work would actually just spin around it and burn out. But you can use a dead center in a tailstock. You can use grease so that you reduce the amount of friction that is there. So that is a possibility, but typically you're going to put the live center in the tailstock. Now, sometimes that's not enough. Sometimes we need to hold the work or support the work somewhere along the work piece itself, not just on the two ends. So you have two options. Number one is your follower rest. So if you look at the red, this red unit here. So this here is our follower rest. What the follower rest does is it mounts through these two bolt holes. It mounts to your carriage. Now remember, when we're talking about the carriage, it moves in the x-axis back and forth towards the headstock and tailstock, right? So what you can do is you can mount this follower rest onto your carriage, and right where those two supports come together, the third support, quote unquote, which is not really a support, but the third point of contact would be your cutting tool. So this follower rest follows the carriage and follows your tool, because your tool is on the carriage. So wherever your tool is pressing against on the work, these two points of contact on the follower rest provide support for your cutting tool as it cuts along the length of your work. The other option there is your steady rest. Now the steady rest doesn't mount to your carriage. We don't want it to move. The steady rest is just like its name states, it stays steady. It's actually mounted to the ways of the machine. And why we would use the steady rest is to support long work as well. Especially if it's really long work, we would use it so that we don't get any swing in the middle of a part. So I had mentioned earlier about work that's long, and we would support in the tailstock the long work, because if we didn't, the work would just do this, right? But depending on the size of the lathe we work on, we could have the work supported in the headstock and the tailstock, and the middle could still swing because of the centrifugal force. So this steady rest will allow us to keep the center of that work from running out of true, right, while we're doing work on the part itself. Okay. And okay, my mic is still on. That's good. Let's just move on then to our last two slides for the lathe here, guys. One of the things that's really important for us to understand is the manufacturing process. Now, this is a whole topic on its own, but we're talking about lathe fundamentals. I just want to kind of cover the basics of kind of the whole gambit here of the lathe. One of the things that we just got to have drilled in us right from the beginning is the manufacturing process. If I'm going to go set up a piece of work on this lathe, I don't want to trial and error my way through this, work all day and get nothing accomplished. I want to set the machine up with a plan, right? I want to create features that make sense in a certain order. Okay, so the reason I put this slide up is to kind of give you something to start from, okay? So this statement here about bad practice, okay? It would be bad practice to cut a thread on an outside diameter only to clamp on that thread to create another feature later. So let's say, for instance, you were trying to make this part. Okay, so right here, it doesn't show it in the picture, but this call out tells you that this is threaded. Okay, so a nut would screw onto this. So if I set this part up and I cut the face of the part, I drilled out the inside, I bored it out, I created this undercut, I cut this outside diameter, I cut this this undercut right here, and then I put this thread on. What I haven't done is I haven't cut this outside diameter, and I haven't cut this taper or this counterbore on this side. So now I have to flip the part over, and what am I going to clamp onto? Well, now I got to clamp on the thread. Bad practice, right? So I set this part up and cut it without thinking ahead, without considering a proper manufacturing process. Okay, so this isn't by any means the only important thing. As you go through and manufacture a part on the lathe in the shop, when you get in there, you're going to come up against obstacles. You're going to, you'll come up against an obstacle before you know it's an obstacle, right? So you'll go and you'll cut a feature, and then you'll go to hold it and be like, oh wait, how am I going to hold this? Or how am I going to get at this feature? So sometimes in the learning part of this, yeah, there's a little bit of trial and error. But we want to try and avoid that, right? Ask questions. You know, if I cut this part, how is that going to affect my next operation? So manufacturing processes is a way of thinking so that we can manufacture a part the right time and with the features cut in the right order to the best of our ability. And in yellow, that's our key, eh? Examine the print. Create an order of operations. Create a tool list. And this is what we see on this last slide here. So I've just kind of demonstrated how my process works when I come to when I approach a new job. I look at the part and I think about, okay, what is the last feature? That's how I think. What's the last feature I have to cut? Because if I'm cutting that feature, I know that I've got to have something to hold on to cut that last feature, and that kind of helps me put my head on straight. So if I were to make this part, this is how I would set out my order of operations, because in my experience, this is what I find works the best. So this isn't, don't worry about this. You don't have to memorize this, but this, you know, you can get access to this when you go back and view the video. If you want any of these slides, you can let me know and I can give them to you. But any part that you create, it's not going to be this part, but this just kind of gives you an overview of how important it is to kind of put a plan together before you start cutting a part. The last thing I do, according to that list or that order of operations, I pick all my tools. So I'll go and grab, you know, like on this last slide, operation 1 is facing the part. So I will make sure for operation 1 that I get the right tool. So I'm going to use a carbide insert turning tool that has a large radius on it. I'll set that aside and I'll put it on my desk in the first place. That'll be tool number 1, because tool number 1 is going to be in that operation 1, number 1, face part side 1. Then I got a center drill side 1. So tool number 2 is a number 3 center drill. So that's how I do this, guys. I go through, I figure out what each operation is, and then I go and pick out my tools. Notice that some of the tools I'll use twice. Notice tool number 1 in operation 1. I can use it for tool 1 in operation 2. So if you look down to operation 2, it's in blue, right? I got to face the length of side 2. Or face 2 length side 2. So I can use the same tool. So this is another benefit of planning your job so that you don't end up with 20 tools when you only need 7. Okay, so this is isn't something that is just going to make sense right off the top, but I think you understand the principle here.